Alright, moving on with equations. We were talking about what happens if there are squares and square roots in equations. So this little thing on the side is helpful. What I'm saying is basically get the squared term alone on one side. So anything that is extra, you have to get it off that side. We're going to learn that you undo squaring by square rooting. If you look at this note over here, they are opposites of each other. They undo. So you undo squaring by square rooting. And actually, when you have an exponent of 2 or squared in a problem, you have two solutions. Why is that? Well, let's just say you have that x squared equals 25. Right away, you might say, well, x is 5. Because 5 times 5 is 25. But remember back to chapter 1, we also said that it could be negative 5 because negative 5 squared equals 25, just like 5 squared does. So when you have a squared, whatever the exponent is, that's how many solutions there are. So let's dive into one of these. Let's take a look at number 1. Step 1 says we want to get the squared term alone on the side. So when we have x squared minus 4, I actually want to get rid of that minus 4 because I want that squared term to be alone. So we undo that by adding 4. And now we get x squared is equal to 36. So step 1 is done. Step 2 now, you undo the square by square rooting. So when I square root, that undoes the squared, leaving us with just x. So notice they cancel each other out. And if you square root 36, remember when you square, you get the positive and negative of it. You get both solutions. So that's what this is saying. X equals positive 6 and x equals negative 6. But we just put it in this little shortcut with the plus and minus on top of each other. Now you can go ahead and check your answer and say, alright, if I plug in 6 there, notice the squared is outside of it because we are just replacing x. So 6 squared minus 4. And we're checking if negative 6 squared minus 4 equals 36. And so we're like, oh, 6 squared is 36 minus 4, equals 32. And then negative 6 squared, remember that's negative 6 times negative 6. So that is also positive 36 minus 4 gets us 32. So, if you're not sure, especially with me gone, plug in your value and see if the solution matches what it should. Okay, let's try the next one. We are asked to first get the squared term alone. Well, if you notice, it actually is. Unlike the first problem, there's more inside of the parentheses than just x, but there's nothing outside of the squared that we need to get rid of. So number 1 is actually all done for us. Number 2 says we have to square root both sides so that we can undo the square. So remember, square root and the square cancel each other. We get that x minus 1 is equal to, when we square root, you will always get the positive and negative of it. And so this is where it's a little tricky. Step 3 says solve for both equations. Well, one of the equations is x minus 1 equals the positive 7. The other one is that x minus 1 equals negative 7. So we're just splitting up into two equations now. What's nice is to get x by itself, we just add 1 here. So we get that x equals 8. When we do that to the other one, be careful, it's not 8 and negative 8. When we add the 1, we get that x is negative 7 plus 1. We're getting closer to 0, so we're at negative 6. So these are the two solutions, and this is why I really want you checking your answers. Because if we plug these back in, we are putting, it was x minus 1 squared. So 8 minus 1 squared. Well, parentheses says, okay, we have to subtract before we do exponents, and we get 49. So 8 worked. Let's try that with the other one. negative 6 minus 1 squared. Well, in the parentheses, negative 6 minus 1 is negative 7. And now when we square that, remember that's negative 7 times negative 7, we do get positive 49, which is what we were supposed to get. So, we got our two solutions. Now number 3 is a little weird because we have a triangle and you're like, there's no equation. But remember Pythagorean theorem, hopefully you've heard that a little bit before, where it says a squared plus b squared equals c squared. These two sides, a and b, make the right angle. They make, this is now a backwards L for leg. And so one of them is going to be 15.2 squared plus 8.0, which is just 8 squared. And it equals the hypotenuse, which is our c. So we don't know that side, so that is, we're saying that that gets to be x squared. So our steps get the squared term alone on one side. Well, the squared term is alone right there. So we just have to, before we undo the square root, we actually have to solve this out. Please use a calculator. In fact, I'm going to pause the video so that I can put my calculations in. Put this in your calculator and see what you get. Alright, you should get 295.04. Again, it's really tempting to want to square root right away. Don't do this, but it's really tempting to want to do this and then be like, oh, my square root cancels my squareds. But square roots actually don't undo addition. Square roots deal with exponents, which deals with repeated multiplication. So you can only square root things that are multiplication and division, not addition. So we have to do it this way, but now we are ready for step 2 to undo the x by square rooting. And so when you square root, you get that x is equal to, remember you get two answers when you square root, positive and negative 17.18. We'll round to 2 decimal spots. Kind of ugly, but works with decimals. Now, I could plug this into check, but I only have 15 minutes allowed on this website to record. So, I hope you just take my word that that is good, and you can always check it back in later if you would like to check that. Alright, then we get to some tricky ones. When we look at numbers 4 and 5, there's a little bit more going on. But, go back to the same steps that you want to get the x squared term by itself. We want to square root and then get both solutions. So, this one, again, a little tricky, but you can't get anything out of the top of that while it's a fraction. So remember, fractions are just division. So if we multiply this by 3, that undoes this divide by 3, leaving us with this x squared plus 6. If we multiply one side by 3, we have to multiply the other side by 3, and then we get, we get 81. And so just like that, by getting it out of the fraction form, it's easy to solve from here. So I want you to pause the video and try to solve for both x values that make this equal 81, and then play the video to see if your answer is correct. Actually, better yet, why don't you check it, and if you plug it in and it equals 27, you know it's correct. But when you're ready, play the video and you can see my work for the rest of this one. Alright, so my guess is that most of you put 8.66 if you got to this spot. And while that's okay, with square roots, actually, if you get a decimal, it's okay to leave it as a square root because that is an exact value. I'm going to show you why that's preferred over 8.66. Because when we plug it back in, so this is where our x is going, we can see down here that when we square root, when we plug it in for x, it's getting squared. So this square root and squared actually cancel each other right away. So we're left with 75 plus 6 over 3, and remember with fractions we only can have one number on top. And so we get 81 over 3, which equals 27. The same thing would happen on the right side. So square root of 75 is preferred, but if you put 8.66, that's fine. All right, our last one here, kind of tricky because we usually think, oh, I want to do my PEMDAS, my order of operations, and so you start to think how you solve for it. But actually, when we solve here, we want to go reverse order of operations. We want to get rid of anything that is addition and subtraction, anything that's multiplication, and then we move to exponents and parentheses. So when you're solving equations, it's actually opposite PEMDAS. So we are going to start with addition and subtraction first, and I see something outside of my square that we can get rid of on both sides. So we bring down our 5, w plus 3 squared, and now it equals 20. Now it's really tempting to want to subtract 3 because you're like, well, we're doing addition and subtraction. But notice that it's in parentheses. So that's actually this last step. We will focus on what's in the parentheses. So for now, we just know we have taken care of all the addition and subtraction outside of that squared thing. Next we move to multiplication and division, and it's kind of weird, but remember when things touch without a sign, it's multiplication? So we're going to divide this side by 5 because that undoes multiplying it by 5. When we do it to one side, we can do that to the other, and so we are left with w plus 3 in parentheses squared equals 4 now. Okay, this looks a lot like question 2, where we're like, oh, it's actually just something squared already. So we can't take care of what's inside of it until we take care of this exponent. Well, to undo the squared, we need to square root. And remember, square root and squaring something undoes it. So we unlocked that w plus 3. But if we square root one side, we square root the other. And remember, when we square root, we get the positive and negative of the answer. And so this is a time where we would have to split it up into its 2. W plus 3 equals positive 2, and then the other one says w plus 3 equals negative 2. So now when you solve for w and you subtract 3, you get that w equals negative 1 for one of the solutions. And then when we subtract 3 over here, we get that w equals negative 5. So it's okay to not have the same number. If we plugged in negative 1 here, or negative 5, it would equal 30 in the end. Okay, so that's squaring. Check out video number 2 for a couple square rooting questions, and then we'll get you working on some homework.